Well, good morning, good afternoon, good evening, wherever you may be, somewhere across our lovely world. Thanks so much for joining us live here on Serverless Office Hours. We are streaming on the AWS Twitch channel and on the Serverless YouTube channel. We were meant to be on LinkedIn Live, but something seems to be a little strange with the timing for that. So apologies if you are hunting around on YouTube, on LinkedIn Live, and you don't know where we are. Pick us up on one of the other channels, please. My name is Julian Wood. I'm a developer advocate for serverless here at AWS, and I am super duper excited to have the one and only Boris Tane, who's the founder and CEO of Baselime. Boris, welcome to Serverless Office Hours. How are you today?
I'm good, Julian. Thanks for having me.
Excellent. And actually, we're not that far apart. We're sort of both on the outskirts of London in the UK, and it seems like a bit of a summer's day today, which is really weird in October. So yeah, south is in that direction. So I'm sort of waving at you across the Thames. So Boris, tell us, how did you get involved in serverless, and what led you to your journey to becoming the big boss of Baselime?
Yeah, that's a very good question. Serverless, who? I think we have to go back 2018 or something like that. I joined a startup here in London, and it was deployed on, I think at the time was ECS containers, not Fargate yet, the old school ECS, and I was then just playing around with tech and deploying random crap, random Twitter bots, etc. before the API was paying, testing things, and I was doing that with Lambda, and I realized, okay, this is actually pretty cool. I don't need to manage anything, and my code is just going to run, and I don't need to worry about anything. I don't have, I used to sometimes use Heroku for those sort of things, but I had always the limits of the dynos, and when it was cold, it was taking 5 minutes to start up or something like that. But with serverless, it was, milliseconds. So that's how I started playing with serverless 2018, around that time.
Well, fantastic. Yeah, we're going to hear so much more all about Baselime, and so glad you're happy to join us. Just looking back over the past week of what's been happening in the world of serverless, at least on the AWS side. The previous stream on the 3rd of October was all about governance in depth. And it was a super interesting stream because it's not just about the governance of your compliance people knocking on your door and going, can you provide me this report and this report? Higgy, Pallavi, and Debasis went through a really comprehensive way talking about proactive controls and detective controls and all the things to make serverless safe in your organization, whether that is big or small. So certainly have a look at that. That's on our Serverless Land YouTube channel, along with all other previous streams of Serverless Office Hours. In terms of what's new that's happening, just some things. Amplify has got a CDK construct, so people are using CDK. Love your CDK constructs. Well, the GraphQL API capabilities are now available. If you're using SAM to build your serverless applications, the serverless application model, the Lambda test events that are in the console that you can create, you can now use locally, so you don't have to leave your local IDE to go and jump off and get those test events. And then also a really cool one, EventBridge, also one of my favorite services. It's like your children. You can't sort of choose between all your favorite services, but EventBridge has really done a good one with wildcard filters in the rules. That's what makes EventBridge, event buses really cool, is the rule pattern matching. And now the fact you can use wildcards means you can use, things like doing a, star looking for a PNG file or a doc file as that comes through on the event. So yeah, super useful things. In terms of blog posts that have been coming out recently, of course, we have to have blog posts about generative AI, and AWS's has come out with Amazon Bedrock. And so I think, serverless is one of the best ways to use all of these APIs via generative AI. And Pascal and Martin have put together a blog post about building a serverless document chat where you can chat back and forth to your PDF applications, which is a really helpful use case. And then Paris and Curtis have got a blog post about designing your application. So this is AWS Let's try that again. AWS Application Composer. I won't try to say that any faster, which is a visual canvas for building applications. Used to be just for serverless applications, and now it's for all applications. Be able to visually connect anything that CloudFormation supports. So that's on the blog posts. In terms of events that are coming up, in 2 weeks' time, there's EDA Day, Event-Driven Architectures Day in Nashville. I will be there with a whole bunch of our team and other people who are super duper experts about the whole EDA. Dave Boyne, you may know him about EDA and experts, and the keynote is going to be James Urquhart, who literally wrote the book on flow architectures, which is all about EDA. There are still a handful of tickets going, but I know, well, hopefully they still are available. I haven't actually checked today, but please, it would be great to see you there. There'll be lots of good content, and everything all about event-driven architectures. And then just a small plug. I'm actually going to be in Cape Town next week, and I'm originally from Cape Town, so it feels as though I'm sort of going home. I always joke when I'm there that Cape Town was sort of the birthplace of EC2. So the Amazon servers were born in Cape Town, and now we're going to talk about serverless in Cape Town. So we try not to usurp them. But yeah, a whole bunch of people are going to be there. Serverless Days, Cape Town on next Friday. And on the Thursday, I'm running a workshop as well. So yeah, if you are in Cape Town and know somebody who's going to be in Cape Town, please sign up. It'll be awesome to see you there, and go and see the lovely mountain. Of course, reInvent is coming up. We're working hard behind the scenes at the moment to put together a great conference with lots of good content. I'm literally deep into my eyeballs in preparing PowerPoint decks and demos and all kind of cool things to show you. So that's happening end of November, beginning of December. Sign up and it'll be absolutely awesome to see you there. It's going to be a good one. Of course, Serverless Land is our page for learning everything about serverless on AWS. And there's a learning page, which we've just been adding more and more learning guides. And these are sort of opinionated bits of information from DynamoDB to APIs to Kafka to Kinesis to Lambda to, I'm just guessing all the other kind of ones. But literally, some of the experts within AWS are putting together these guides, which take things from documentation and other videos and best practices and make a really well-crafted narrative to help you build serverless applications. So that's the past week, but looking to this kind of week, we're talking about Baselime and serverless observability. Now, Boris, I've done a fair amount of observability stuff in my time, way before the serverless world, and particularly even at AWS, I've done a lot of work with our whole sort of Lambda and serverless ecosystem. There are obviously a lot of options over here. What was your thinking process to go, I'm going to build an observability company. There's more still to do.
Yeah, you're right. There are a few options when it comes to observability for serverless. Even on AWS, we have CloudWatch and X-Ray. But I think the real issue is in the developer experience. What is happening is almost everywhere I've worked, and based on hundreds of conversations I've had, in every single team, there are 2 or 3 people that are the observability guys, the guys that know how to go around the logs, the guys that know how to go about the traces. And then the rest of the team is basically, require, like the rest of the team needs them to be able to understand how production works. Whereas when there is an incident at 2 a.m. and you get paged, you're not going to wake up somebody else if you have the right tooling to be able to understand your system yourself. And that's the whole idea of Baselime, to take all of that telemetry data that is available everywhere, put it together, index all of it, make it searchable, make it queryable, and always give a path to the next question. I think one of the biggest issues with a lot of the tooling around right now is that you can get stuck. You can get to the point where you open the CloudWatch log stream and you're like, okay, there is an error here, but why? Is it connected to another function? Is it connected to a stream? Is it connected to an SNS? Is it connected to an SQSQ? I don't know. The whole point is giving the ability to every single developer to go from one piece of information to the next one and keep, investigating until they actually understand what is happening in their systems.
So is this bringing it front and center that the developer's in control, or whoever's building it in control, and it's not just sending tickets over to find what's going on? And I suppose the idea with that fast feedback loop, not just when things are wrong, but also when building applications.
Absolutely. What we're seeing is actually people using Baselime more for when they are building their application than for incidents, because at the end of the day, if you have great observability, incidents become relatively trivial because you can really quickly identify what's the problem and fix it. Whereas when you're building and you're exploring, sometimes you have some unexpected behavior that happens and you need to understand why it's happening before it actually gets to production.
Okay. And is serverless observability markedly different from what people have done before when it was servers or even containers or non-serverless things? What's the sort of challenge and the difficulty, and or maybe it's easier? What's easier and what's difficult?
Yeah, there are definitely challenges. First of all, how much more distributed the applications are, right? When you have a container-based application, typically you'll have 4, 5, maybe 10 containers, maybe 20 containers, or services, quotation marks. When you are in a serverless architecture, easily 200 Lambda functions, 1000 Lambda functions, like without even realizing. It's just, hey, I need a new route, new function. That large scale of how much more distributed the applications are is a defining factor of observability for serverless. And the second thing is actually instrumenting the application without impacting the performance of the applications. That's a big problem that a lot of solutions completely miss right now. So you have gigantic SDKs that triple your cold starts. You have Lambda layers that are not optimized that triple your cold start and actually impact the performance of your functions. And I've seen a few solutions that are actually sending the traces back to the kind of central place synchronously. Like a customer makes a request, the request is processed. Normally you should respond to the request and then ship the rest of the data asynchronously without impacting the performance. So all of these points make it fundamentally different from, typical kind of container architecture where stick an agent running right next to the application. It can scrape all the metrics, all the logs, all the traces as the application is running and sending them to the backend. Those two main challenges are what makes observability for serverless different.
Okay, so tell us how. I know you've got some info to share, but yeah, tell us sort of what's the premise of Baselime and how's Baselime then addressing all of this?
Yeah. First
Should I
of
bring
all,
up your deck or do?
Yeah, I think the deck is more to help people build, so to tell the story of how we built it. But how does Baselime solve this problem? First of all, using OpenTelemetry and instrumenting your functions without impacting performance whatsoever. So that's the first thing, integrating with layers and extensions that are optimized to not impact performance. The next thing is high cardinality and high dimensionality. That is something that even solutions like X-Ray are a bit missing, which is the fact that every single piece of information that you add to your telemetry data should be indexed such that you can search through it, right? Like it's, at least in my opinion, right now, when you open X-Ray and you want to get a trace, you can get it traced by trace ID. But if I have a user ID and I didn't put it in the metadata of the span, I cannot find a trace or all the traces that this user touched, quotation marks, whereas that's what's important to me. And we are then shifting the responsibility to the developers to continuously, in every single span, say, add this metadata, add this metadata, add this metadata, whereas on Baselime, everything that you send is indexed by default. And one other really important thing is the speed of the queries. I think even with older solutions, I've worked a lot where you run a query, you go take a coffee, and you come back before you get the answer, especially if you're running a query on like 1 week worth of data. That is not awesome, because when you're in the heat of an incident, you're already sweating because production is down, and your boss is probably going to message you really soon to understand what's going on. You don't want to be sitting and waiting for a spinner to load because it's running a query. So yeah, that's basically the idea behind how Baselime is different from the other providers that are out there.
And just can you explain, because I know some people hear the terms the cardinality and dimensionality, having the wide options for that. What do those two terms mean for people who are not aware, or it's confusing?
Yeah, high cardinality simply means that you can send. I will take an example. It's probably easier to visualize it. A request ID, for example, is a high cardinality piece of information because it can take millions of different values every single day, right? Like every single request is one new request ID, and indexing every single one of them such that you can search through them has some computational expense because they are so different. Like every single time you have a different request ID. And high dimensionality means that your objects that you send to your observability provider, whether it's logs, metrics, or traces, are wide. They are large events with many fields as you can. So for example, a metric on CloudWatch will have 5, maybe 6, 7 fields. That is not a high dimensionality object. Whereas a span of a trace or a segment in X-ray will be a high dimensionality object, because you might have 1,000 different keys in that JSON object that you send to your observability provider, and your provider needs to be able to index every single one of those 1,000 keys, such that if today you need to run a query on request ID, you can. If you need to run a query on user ID, you can. Tomorrow you have an incident that happens only when a specific header is different. You need to be able to identify that it's because of that specific header, and you need to be able to query that specific header too.
Okay. No, thanks for the explanation, because I know some people do wonder what those two terms mean.
Cool. Okay, so shall we get started with the little presentation?
Yeah, certainly. And in fact, just remember, because we are live here in office hours, send us your questions, send us your comments. We'd love to hear from you. Even let us know where you're from. It's always nice to find out where in the world people are watching from. So yeah, over to you, Boris.
Cool. So yeah, this is a little presentation on how to build your own. Let me actually go full screen. Probably better. How do I do that? Here. How to build your own observability platform with the kind of constraints that I highlighted earlier that makes Baselime different. So the idea is, I just want to share with you guys how we work internally in Baselime and how we were able to achieve what we just discussed. So typical serverless architecture, as we mentioned, really distributed systems, and it becomes extremely hard to understand what's going on at any point in time. And about me, we went through a little bit of it. 2015, graduated in aerospace engineering. 2019, I was working at a startup in London as a software engineer. And then I started building, startup in 2021 with a bookmarks manager for Teams. And in late 2021, I started Baselime. So the whole point of Baselime is to simplify the complexity of cloud applications. 2015 or so, when I was graduating, you will deploy one application, one monolith into a DigitalOcean or an EC2 instance, and you will run with it and it will be awesome. Today, you have containers, you have functions, you have edge, you have, all of these things that just make your application sprawl, quotation marks, out of control. And our goal is to really help people simplify that complexity. And how do you simplify it? Is by understanding how your software works by looking at its external outputs. That's our definition of observability. It's not logs, metrics, and traces. It's not any of that. It's giving you the power to understand how your software works by just looking at its external outputs. You don't need to change your code. You don't need to change your software to understand how it works. All its outputs should be able to tell you how the internals of the application are working. So we want to build our observability solution. What are the constraints? First of all telemetry data must be indexed, queryable, and searchable. I don't know if you have a question.
No, not a question. Sorry, I was just noticing that someone was from Minnesota, and we had Otzi official from Germany. So I was just saying hi.
Nice.
No questions, just telling us where they are.
Cool. So yeah, all telemetry data must be indexed, queryable, and searchable. That means that high cardinality and high dimensionality I was explaining earlier. Every single thing should be indexed. Secondly, our queries should be fast. You should be able to query 14 days worth of data within 1 second. You don't need to take a break, have a coffee, whilst waiting for your data to come back. The other constraint is near real-time ingestion. So as soon as the data is produced by your system, it needs to be available in our tooling for querying. And that is really important because I've worked with a few tools where the data was delayed by 5, 10, 15 minutes. And when you're in the heat of an incident and you're looking at data that is old, it's actually quite hard to understand what's going on, because if you're testing, you make a request, you need to wait 15 minutes to see the data appear. You might as well just go and have a coffee too. And it needs to be cost effective. It's 2023, it's not 2021 anymore, when money was quotation marks free. So we need to be able to have all of these, but without breaking the bank. So how do we get there? There are a few elements that are really critical to building an observability solution like this one. First of all, we need to be able to instrument the application. We need to collect the data in near real time. We need to process it, and we need to visualize it. And the last one is my favorite one. We need to provision it. We need to be able to also automate all of the things that we do with our observability. So the instrumentation, here we have an example of a typical kind of serverless application. You have a browser that makes a request to an API gateway, which produces a message that is in SQS, invokes a function, the function writes in a table, in S3, events left and right, etc. This is exactly the sort of thing that is extremely hard to debug, because if the issue is between API gateway and SQS, you have no idea. If the issue is when the second Lambda publishes to SNS, you have no idea. You need to be able to view the flow of a single request through all of these such that you can understand what's actually happening. And for instrumentation, you need a few things. You need to capture all your logs, capture all your metrics, capture all your traces, but also capture what we like to call wide events, and some other people call them canonical logs. Some other, like, it has a lot of names, but any event that is part of your application that is not a log, a trace, or a metric, you should be able to send it to your observability provider too. And this is what a trace typically looks like. For those who have used OpenTelemetry or X-Ray, they will be familiar with this. But for those who haven't, a trace is basically a way to visualize the flow of a request through multiple distributed systems. I can use my mouse actually. So here we have the root span, which is typically where the request entered. In our previous example, it will be the API gateway. And then all those kind of child spans are all the processes that this initial call created. So here we will have one Lambda function that is making a call to DynamoDB. Here we will have another Lambda function. Here we have another one that is making a call to an ECS, that is making a call to SNS, that is ultimately writing to EventBridge or something like that. So this is the typical structure of a trace, and we want to be able to capture this from our applications. And for that, we are going to use OpenTelemetry. OpenTelemetry is an open source project that encompasses all the best practices about distributed tracing over the past few years, such that you don't have to build everything from scratch again. You can literally stand on the shoulders of OpenTelemetry for your instrumentation. And the way we're going to do it is using a Lambda extension and a Lambda layer. So we're going to have a Lambda layer with the OpenTelemetry SDK installed in it, such that we can add it to our functions without changing our function code. It's kind of auto instrumentation, and it's going to capture all the traces from that function. And then we are going to use the telemetry SDK to, not telemetry SDK, telemetry API, to have a Lambda extension that then sends all the logs, metrics, and traces to the observability backend asynchronously, not part of the flow of the Lambda call. That's our instrumentation covered with OpenTelemetry, Lambda layers, and Lambda extensions. Now, how do we collect the data? We want to do it as serverlessly as possible, so we're going to use Kinesis data streams. So when the SDK, the OpenTelemetry SDK, collects and pushes all the logs, metrics, and traces, we have a Lambda function in front of it, and then that Lambda function writes directly into a Kinesis data stream. And for long-term storage, we also push it to Firehose, and we store it in a bucket such that we have all of that data available for us, long-term in cold storage. The next step is transformation. Let's see if so processing and transformation. How do we do that? We use ClickHouse. ClickHouse is the fastest open source database in the world. And it's really interesting because it stores data in columns rather than rows. So your typical Postgres, MySQL database will store, one item as a row and the next item as a row. So data in the disk is close to each other by row, whereas ClickHouse will do it by column. So when you store a new row in ClickHouse, a new item, it actually doesn't store the row together on disk, but it stores the columns together on disk. That enables them to do really, really fast analytics queries, because let's say you have one column that is lambda cold starts, and you want to compute the average cold start of all your functions. It doesn't need to read your entire disk to get the cold start from all the rows. It can just read the cold start column, and from there be able to surface the average to you. So using ClickHouse is enabling us to get that speed. So yeah, that's what I explained here. Open source columnar database designed for high performance analytics. I'm sure you can get that on Wikipedia. But
so a lot of people have, because I mean, I know a lot of other companies have literally had to write their own database to do this because of that high cardinality and that high dimensionality. So was ClickHouse just an open source thing that has come out since then that ticks all the boxes? Because that seems great.
Yeah, so ClickHouse doesn't check all the boxes, checks the vast majority of the boxes. We had to build at Baselime our query engine on top of it to have quotation marks infinite dimensionality. So ClickHouse is really fast, but you still have a limited number of columns. You cannot just have 10,000 columns per event. So what we did with our query engine is some data transformation that is enabling us to use ClickHouse with its limitation. I say limitation, it's the best database in the world. I absolutely love it, but it still has limitations. We've been able to use ClickHouse with those limitations and still be able to have high dimensionality and high cardinality.
Okay, cool.
So why did we use it? Possibly schemaless, such that we can have all those columns as we want. High cardinality. Multi-tenant, that is super important for us, given that we have multiple customers around the world and we don't want data to be shared. And it's fast. It's insanely fast. It's probably, if you go on the ClickHouse website, it's the one thing that they brag about. It's literally at the moment the fastest database in the world. So how do we do that? That's the one place that is not serverless. There are a few initiatives on having ClickHouse serverless, but for now, still have to run it into EC2 instances backed by EBS. You can do backed by EC3, it's just a little slower. So we decided to go with EC2. We have a fleet of ClickHouse clusters with multiple EC2 instances. We use S3 for backups and for anything cold storage. So we keep about 30 days worth of data in hot storage so that you can query that really, really fast. And anything older than 30 days, we put in cold storage such that you can rehydrate your data at a later point in time if you want to run queries on it. So that's our processing with ClickHouse. Visualization. So visualization, when people think about visualization, usually it's pretty dashboards. Pretty dashboards are nice, but I don't think they're actually what great visualization is about. What great visualization is about fast queries. You can have the prettiest dashboards, but if they take 3 minutes to load, they're not as helpful as any dashboard that has really, really fast queries. Real-time alerts. You actually don't want to be looking at your dashboard to know that there is a problem. The solution should tell you there is a problem, and then you look at the dashboard to investigate the problem, not to discover that there is a problem. And we put that into the visualization bucket. And also API CLI access. So having that data in ClickHouse indexed, fast queries, it's all good. But if the only way of accessing it is via the website, it's actually not great for developers, because developers want to tinker, developers want to play around, developers want to automate. We have people that are building self-healing systems where a real-time alert is calling a webhook that is triggering a Lambda that is doing something in their architecture to remediate the problem in real time, rather than them having to log into a console to be able to do that. So those are what we call really key aspects of visualization beyond the pretty dashboards. So yeah, this is how it works. We have ClickHouse that is sitting here with all the data. We have a fleet of Fargate instances that are enabling us to run really, really fast queries. And we have a set of APIs that are calling those Fargate instances, both from the console, but also from the CLI. And we also have integrations with, your favorite tools, Slack, VS Code, Jenkins, GitHub, etc. And we have alerts that are continuously querying the Fargate instances, the ClickHouse through Fargate, to be able to send you real-time alerts. And something that we have actually very recently launched is real-time API, where as soon as the data is in ClickHouse, actually, this is not correct. This should be here. Before the data is even indexed into ClickHouse, we can send you alerts based on things that are actually critically wrong. We do that. It's really, really popular, but it's, again, using Kinesis streams to be able to do that really, really fast in real time.
So this is happening even before you've stored it in the database. So this is this Kinesis EFO, I presume, just 70 milliseconds straight through to your front end.
Yeah. So if you have, for example, the main thing that we are using this for is alerts on errors. So if you have critical errors that you have flagged in your application that these are critical, because we all the data manipulation that we do before putting into ClickHouse, we do it in memory, and from there we can identify this is a critical error, send it to the client before actually putting the data in the database. And it's been working really, really well so far. Cool. So now we have our visualization. Now provisioning. Provisioning is the one thing that people are not, some people are familiar with, but not everyone. Automating creating your alerts and your dashboards. Usually what happens is you write your code, you ship it to production or to test, whatever, ship it to prod afterwards, and go to have your weekend. And then on Monday, you realize that, whoops, the app was down all weekend long, and I didn't know. Why was that? I forgot to create the alerts in the dashboard. Whereas if you had a way of automating it through infrastructure as code, you wouldn't have that problem, because every single critical alert will be created at the same time as you're deploying your code. You don't need to do that afterwards manually. And that's what we do. We have a CDK package that enables you to, for example, here we have a query that is or counting the cold start, the maximum cold start of our function, grouping by service, and ordering in ascending or in descending order, basically. So you can just put this and hook it into an alert that is going to alert you if the value is above, 15 seconds. 15 seconds for cold start is a bit high. Let's say 1.5 seconds. Then you know that you probably mispackaged your application and you need to do something about it. And you can have it as a template and basically reproduce it in all your applications. Every single new Lambda function that is deployed automatically has this query. You don't need to remember about it. You're going to know if any of your functions has extremely high cold starts. So that's basically the idea behind observability as code. This example is with the CDK, but it works with Terraform, working on Pulumi at the moment. It works with CloudFormation as well. So you literally just add this and you have all your alerts and your dashboards set up for you. And yeah, this is how it works. It works using CloudFormation custom resources. And there we go. We basically have our observability solution going from the instrumentation with OpenTelemetry, the data collection with Kinesis, the processing with ClickHouse, visualization in your browser and via your CLI and your APIs, and the provisioning using the CDK, Terraform, Pulumi, SST, etc. That's the simplified version. This is a more realistic version. It's still simplified, but getting all of that data is not as simple as checking it into a Kinesis stream. You need to have a few things in between, the processing, the collectors, etc. So this is what it looks like. And I can probably give you guys a short demo right now. What I'm going to do is open sandbox.baselime.io. Hopefully nobody deployed. There we go. So this is the Baselime sandbox. Out the box, you have the number of events, the number of errors, your request latencies. And what I was saying at the beginning about what's the word? Developer experience. Here, I automatically have a list of all my requests, and I can open any of them and see all my logs for those requests. And clicking here, I can see a trace for this specific request. I don't need to do anything. The request is on the Poké. Oh, I should probably make it a little bigger so that people can see. Let's do this. The request is on the Pokédex list function, which is this function here. But the trace tells us that the actual origin was from this get call that if we open it, we can see that it was a Fargate service, and this is the ARN. So with very little effort, I'm able to identify that a Fargate service somebody made a call to a Fargate service that then made a call to a Lambda function that then made calls to DynamoDBs and Kinesis. And I can also view the timeline of how exactly this has been happening over time. And when we were speaking about high cardinality and high dimensionality, let's take, for example, this found a list of Pokemons with the value 10. All of this is automatically indexed. So I can do something like filter by matching events on any of those, and I can match anything where the message is find a list of Pokemon. I can do equal, blah, blah, blah. I have all these operations there. Let's do equals. And it's adding this filter and it's retrieving all the requests where there is one log where message.message is found a list of Pokemon. And that's simply because everything is indexed. So that event was a little small. Let's take a bigger event. Here we have, this huge event which has all the headers, etc. Let's remove this auto filter and filter on one of those really large events. Here, let's say we want everything that was called by desktop. We can filter by matching event, add that filter, and it runs the query and it returns all the requests that were like this. And you can do this across the board. The real-time errors that I was talking about, this is basically how it works. As I mentioned, before the data is even ingested into the database, we have a stream that is verifying, if this is an error, this is an invoke error, we can open it, we can investigate it. We have the sample event, we have the 30-day history, and we can investigate deeper where we get into the query builder, where we see how it's been happening over the past hour. And what I was talking about, the query speed, 47 milliseconds to run this query. That's the sort of query speed that we want because it's just 1 hour. If you want to run 1 day worth of query, it's 63 milliseconds. That's the sort of query speed that we need to be able to go from one piece of insight to the next one. Here we are viewing the events. We can also view some sort of calculations here. Let's remove all of these. And for example, we say we want to compute the cold starts. So I want to say visualize. I want the P90 of my cold starts. And I want to group them by service. And I want to order in descending order, and I can run that query real quick. And I have only one service in this demo account, but in 42 milliseconds, I was able to know that my P90 of cold start is 847 milliseconds over the past day. That's the sort of operations we need to be able to do with the observability solution that we use. You can have dashboards, of course, and alerts, those sort of things, basically.
Yeah, I mean, the speed is impressive. I love the fast searching for everything. You can see how responsive it is rather than clicking and having to find out things. One of the things I know developers sometimes struggle with is things are going wrong, but they don't quite know what yet, or where to even start, or is it Lambda latency? Is it API gateway throttling? Is it where does it start? How would Baselime be front and center where, a customer's phoned up and something is wrong, or you just know that something is a bit weird on your site? What's the sort of entry point to sort of highlight where things that you don't know yet are going wrong?
Yeah, so let's take an example. You said, let's go back to 1 hour. You said a customer tells us that something is going wrong. Here, unfortunately, we don't have user IDs, but it's a Pokédex. So we know that somebody is searching for Pokemons. Let's say that someone tells us, hey, I searched for Pikachu and I couldn't find it. Come in the search box, type Pikachu, surfacing all the requests that had the word Pikachu in there. This one is red. It was probably an error. You can click here, Pokemon not found. The person typed Pikachu instead of Pikachu. But why did they type that? I can view the trace and see that we had this function that made a call to DynamoDB. I can view the timeline. Took 17 milliseconds, so it's not latency. They don't have a latency problem. It's definitely because they put the wrong name. But I am still not convinced that is the problem. I want to know if latencies for this get function is a problem. I can start a new query and query again my Lambda logs, and I want to view add visualization. Yeah, I want to see if that specific function has a latency problem. So I can put here, no, duration, sorry. Duration, that's the one. And I want to filter for that specific function. So function name is the get. Baselime is helping me. I don't even need to remember the name of that function. And that's about it. I can run that query and I can see that it spiked in latency here. Why did it spike in latency here? I can zoom into that and go into requests, and I have all the requests that were during that time period. We can see that these two took 168 and 52 milliseconds, whereas everything else is in the 60 milliseconds or so. So let's open this one to see exactly why. I can again open the trace, and we see that the DynamoDB calls took 15 milliseconds. The function execution itself took 16 milliseconds, but the function latency here is 168. It means that it was probably a cold start. And one of the limitations of OpenTelemetry at the moment is it doesn't capture cold starts. So we don't see the cold start on the trace. But by being able to know that here, our actual function latency was 16 milliseconds, but the total latency was 168, we can inform that the issue is definitely outside of the function execution. We had a cold start here that was a little bit too high. Now I can go into my code and see if I have the Node SDK bundled incorrectly or something like that. That's basically the flow. You always have something that you can work with.
Okay, yeah, I mean that's good. I think as with all observability providers, you need to know your architecture and you need to know the services that you're working with and the limits and how things work. No observability is going to be a magic box, but I see how quickly it is to come back with things, and you can just, it's so quick to query around that I can see the use case of just finding things out. Visually, it's very easy to see that was 168 milliseconds.
Yeah, absolutely.
So another question I have is this only for serverless applications, or can you ingest anything that's from OpenTelemetry?
Yeah, so our OpenTelemetry, we are fully OpenTelemetry compliant. So anything that is coming from an OpenTelemetry SDK, you can send to Baselime. It's going to show exactly like this. We have a few customers that are not on AWS and that are sending data from other kind of application deployment platforms. One very interesting thing as well, I think we saw it, if I come back here, we saw that you can also instrument Fargate services, and it's just a container. It means that you can instrument any container you want, and you will get logs, metrics, and traces available into Baselime.
Okay. Do you then, you were talking about the Lambda layer and the Lambda extension for OpenTelemetry. You don't use the stock standard OpenTelemetry extension, do you? You have to do your own, because I know there are some, the OpenTelemetry code has been written for a container slash EC2 world where there is a slow startup time. So you must have optimized that to work in Lambda then.
Yeah, so OpenTelemetry was built for a world where it's a fantastic tool. It can instrument everything, literally anything that you have. But it means that for serverless workloads where memory has to be managed and the size of the bundle has to be managed, it's a bit trickier. So yeah, we spent quite a bit of time working out where in OpenTelemetry it's not absolutely necessary for instrumenting Lambda functions and including only those bits into the layer, and giving the possibility to developers now, if they need, for example, we don't have the instrumentation for, I don't know, Bluetooth, if OpenTelemetry can instrument Bluetooth.
Yeah.
If you need that, you can then install that piece of SDK yourself into your code, and the layer doesn't come with it.
Okay, that's interesting. So also then you were talking about having to have very little instrumentation of your code. Baselime is just going to grab that via OpenTelemetry. Is there any additional metadata or anything that people can put in their code to help, or it's just not necessary? What's the sort of, I suppose, the delineation line between what Baselime is going to do to you, going to do for you, and then what you also need to instrument in your code? And actually, I've just seen a question that's come up via SidSSN16 from Twitch. Thank you. Yeah, this is sort of on the lines I'm thinking. If we're integrating with Baselime, what is our responsibility? Is it something like we do for Splunk, where we constantly stream all the data that we generate with the help of the OTel layer? So yeah, so slight different takes on the two questions. What does Baselime do, and what do you need to do to either generate that metadata or code in your functions or that kind of thing?
Yeah, so I think if an observability provider tells you don't need to do anything, they're probably lying. We don't know. Let's say you're an e-commerce website and you have an inventory with prices and you want to be able to surface the price of the item that always causes errors. We cannot capture that unless you add that metadata to your traces and to your spans and potentially to your logs as well. But we are going to capture everything that is quotation marks free. Let's take DynamoDB, for example. Here, we have captured the operation, the statement. It was an update item to this table. This was the key. This was the update expression. All of these things that we can capture without you having to do anything, we will do that. But there are things that are fundamentally part of your application that like the provider simply cannot get without input from the developers.
Okay, yeah, that makes sense. So does this then, so there's two parts of it. One is the OTel, which is the collector sending it to Baselime, and then obviously there's a Baselime CDK, Baselime SDK that you're going to then import as part of your function package. So sort of what languages do you then support for that SDK?
Oh yeah, that's the beauty of it. Given that we use OpenTelemetry, we actually don't have an SDK. You install the OpenTelemetry SDK and you can use it. So there is no need for proprietary Baselime code into your application. We have a small logger for the tiniest logger possible for people that just want to have better structured logs. Some people are using it, but fundamentally, if you have the OTel layer, you can install the OpenTelemetry SDK and have all the beauty of OpenTelemetry without relying on Baselime.
Super interesting. I hadn't captured that. So that's super interesting. So yeah, it's not another SDK for another observability provider. You just use your OpenTelemetry SDK, and the OTel extension is then just going to grab all of that telemetry and send it to Baselime. But that's an industry standard, so it could be honestly sent anywhere. But you're obviously optimizing the collection of that and then sending it to the platform.
Yep.
Yeah, and Russ Riguez from Twitch, thanks for joining us as well. Says, I like that you are relying on OTel rather than your own SDK. Nice touch.
Thank you.
So I suppose then, there are OTel SDKs available for all languages anyway, and that's then not something that you need to maintain or support because it just comes from OTel.
Yep, and we are contributing to OpenTelemetry as well. Thomas and our team has made quite a few PRs already, and we are going to keep doing that as we grow.
Excellent. So how does one? Well, first question actually, Sim, you're talking about the integrations. Got all the lovely icons on the screen for things that aren't code based. That's not in a Lambda function. One of your examples previously was API gateway talking to SQS. How does the sort of collection of that data happen then?
Yeah, that's one of the current limitations of the Lambda layer, because it's built. It really focuses on the
Lambda, yeah.
compute layer, but there are two ways. First of all, we also integrate with X-ray. This specific example doesn't show that, but we can get all the X-ray traces as well.
Yeah.
And one of the projects we have internally is merging the two, such that you get the API gateway to SQS, etc., from X-ray, and you get the Lambda kind of piece from OpenTelemetry. That's something that we're investigating. It's definitely possible. And the other thing is we can also get linked traces with OpenTelemetry. Our current layer doesn't support that, but it's also something that's in the works at the moment.
Okay. Yeah, I suppose that's a really interesting thing that some people may not be aware of, that, X-ray is going to propagate those trace headers actively between a whole bunch of services. And obviously there's no code to interact with that. And that is things like SQS and things like EventBridge, where it is all, asynchronous. Things just happen, but that trace header does get passed along. And it's really... It's interesting to know, and I think some people don't realize how they can use those X-ray trace headers, not necessarily with X-ray, but with other tools like yourselves, and be able to sort of tie those two parts of a query that happened, and then when it does get to a Lambda function, you can then, have all that trace header history.
Absolutely, yeah.
So then, in terms of pricing and getting started, people can go to the website. You sort of, what kind of customers are you targeting? I presume as many as possible. But if somebody is watching this and they're thinking, could Baselime be for me? What would you be telling them?
So it will highly depend on their architecture, right? If your architecture is mostly EC2 instances running, it's probably not the best. It's going to work, but you're going to do a lot of manual work to get the instrumentation working, etc. Whereas with Lambda, you add a tag to your functions, and we add the layers and all of that automatically for you. So it's typically anybody that has an architecture that is mostly serverless. So Lambda, Fargate, ECS. App Runner is also a big one these days.
Cool, yeah.
Yeah. And with all of these, typically what we are seeing is really teams that are optimizing for their speed of delivery more than anything, because with great observability, you basically increase your speed of delivery. And you also mentioned pricing, completely free up to 4 million events a month or something like that. And one event is basically one giant span like this. So ideally, we want people to put as much metadata as possible onto their spans, such that it gives them the power to actually know what's going on in their application. And then it starts at $20 a month after the free plan, and it grows linearly with the number of events that you send to our backend, basically. So yeah.
Excellent. I like the transparency and the simple to understand. So that's really good. When you were just talking about the Fargate, how would Fargate and App Runner, how does the collector then work? Because you haven't got a Lambda layer. Is there some sort of OpenTelemetry that then is going to send it to the Baselime API? How does that work?
Yeah, so I can probably show you real quick in the query builder here. These are all the data sets that we support out of the box for AWS. So your API gateway logs, your App Runner logs, your CloudTrail events, your CloudWatch metrics, your ECS logs, your Lambda logs, OpenTelemetry, of course. Web is anything real user monitoring, and X-ray is AWS X-ray. And for ECS logs, for example, we use Firelens to ship all the logs directly to Baselime. And for tracing install the OpenTelemetry SDK, wrap your Express.js or your Java, whatever, and just put the endpoint and the API key to be Baselime, and it's going to appear in here. And same thing for AppRunner. For AppRunner, AppRunner writes all the logs in CloudWatch by default. So we have subscription filters that get all the logs from there. And for tracing as well, install the OpenTelemetry SDK, put the Baselime API and the API key, and it's going to appear in here.
Excellent. Boris, super fascinating. Philip, hello, how are you? Nice to see you again, even remotely. Philip, one of our AWS awesome serverless gurus. Sending you the message I would have. Great work, Boris. Before we do say goodbye and just wrap up, I just want to remember about the serverlessland.com, everything to do about serverless on AWS, and the learning page, which had all those kind of cool things. EDA Day in Nashville in 2 weeks' time would be awesome to see you there and talk all about it. You know, when we're talking observability and we're talking about asynchronicity and all these kind of things that Werner was even talking in his keynote, observability becomes super duper important. So come and learn about event-driven architectures. And of course, it'll be awesome to see you at reInvent at the end of the year. But yeah, before we go, Boris, that's a whistle-stop tour of Baselime. I love how so many companies like yourselves are really taking on the observability challenge. I think one of the challenges with serverless is it gives so much power to developers to build these distributed applications. And although distributed applications are hard, they can be so powerful in building really flexible architectures. But observability is key. And so I love that there's great innovation going on in this. And I've worked with Lambda and extensions extensively. And so it's really great to be able to see how Lambda is able to integrate with all these other partners and to be able to, give as much data as we can to yourselves, and you can graph and visualize and make that all. So yeah, really appreciate the work that you're doing, and yeah, good luck. If people need to get in contact with you, let me see, I did have your contact details over there. I'll just stick it up again. So via not Twitter, it's X nowadays. I'll never get used to that for a while, and via LinkedIn, and then also baselime.io. Well, Boris, thanks so much for spending time with Serverless Office Hours. Hopefully I'll get to meet you, a little bit closer in person rather via the interwebs, and I'll, wave down south in London to say hi. Are you going to reInvent this year by any chance?
Not this year.
Not this year, fair enough.
We're shipping this year.
Cool, fair enough. Well, I won't see you then, but we live in London, so I'm sure our paths will cross. But yeah, appreciate your time, and same time, same place next week. I realized I didn't actually talk about next week. We actually have Dave Boyne, my colleague, and he is the EDA guru, and he's going to be talking to Lars Jacobson, who has written some incredible tools all about event-driven architectures to do with SAM, EventBridge CLI, a whole bunch of tools. Lars is awesome and an absolute serverless guru. So that'll be on same time, same place next week on Serverless Office Hours. I won't be hosting next week, so make sure you look after Dave for me, and I'll be back in 2 weeks' time. So thanks again, Boris, and thanks everyone else for joining us. And I won't see you next week, but I hope you will join us to see Dave. Bye-bye.